You know that feeling when you step outside on a scorching hot day and your body somehow manages to keep you from literally overheating? Or what about when you polish off a giant sugary meal and your system just handles it? Even something as simple as standing up too fast without passing out. Your body is constantly, quietly fighting off extreme changes from the outside world just to keep you alive. Welcome to This Explainer. Today, we're going to unpack the absolute biological superpower that is internal balance.
Here's our roadmap for today. We've got 1. The meaning of homeostasis, 2. 3 indicators of balance, 3. The negative feedback loop, 4. The positive feedback loop, and 5. Why maintaining balance matters. Let's just dive right in.
Section 1. The meaning of homeostasis.
Okay, look at the definition here, but I want you to focus on the idea of this being a self-regulating process. The key concept is that it's dynamic. Homeostasis isn't just some static, unchanging state where your body just hits pause. No way. It is a constantly shifting, dynamic hustle. Your environment is always changing. It gets hot, it gets freezing cold, you eat a meal, you go for a run, and your body doesn't just stop. It quickly reacts and makes these continuous, tiny adjustments to keep everything perfectly balanced so you can actually function.
So you might be wondering, what happens if this balance actually breaks? Well, the stakes are incredibly high. If your internal conditions get thrown off balance, and your body just can't adjust to those external forces anymore, you're in real trouble. An unchecked imbalance leads straight to severe illness, organ failure, and, worst-case scenario, death. That is exactly why this invisible balancing act is so absolutely crucial for us.
Right, moving on to Section 2, 3 indicators of balance.
Think of this table as your ultimate visual cheat sheet for how your body tracks its stats. It's constantly monitoring body temperature, aiming for a sweet spot of right around 37 degrees Celsius. It's also tracking blood glucose, or your blood sugar, trying to keep it between 70 and 99 milligrams per deciliter when you're fasting. And of course, blood pressure, aiming for that classic 120/80 mark. If any of these numbers drift too high or dip too low, your body launches a massive, coordinated response across your nervous, endocrine, and circulatory systems to fix it.
Let's zero in on temperature for a second. When you get way too hot, your body starts sweating to cool you down, and it also does this thing called vasodilation. This is a brilliant move by your circulatory system. Vasodilation is basically the widening of your blood vessels right near the surface of your skin. It's kind of like opening up extra lanes on a jammed highway to let more traffic through. It lets warm blood float closer to the skin to release heat. On the flip side, if you're freezing, your body shivers to generate heat and triggers vasoconstriction. That narrows the vessels, like closing down highway lanes, which keeps that warm blood trapped deep inside your body to conserve your heat.
Now, for blood sugar, we gotta talk about the pancreas, because it is incredibly clever. Say you just crushed a massive sugary treat. Boom! Your blood sugar spikes. Your pancreas immediately steps in and secretes insulin, a hormone that tells your cells, hey, absorb that glucose, bringing your levels back down to normal. But what if you skip lunch and your blood sugar totally tanks? Your pancreas just switches gears. It releases a completely different hormone called glucagon, which tells your body to dump stored glucose back into the blood, bumping you right back into that safe target range.
Section 3. The negative feedback loop.
Okay, so how does your body actually know when to pump out insulin or when to start sweating? It uses what's called a negative feedback loop. And let's clear something up right away. The word negative here doesn't mean bad or harmful, not at all. In biology, negative feedback just means counteracting or reversing a change. If a level goes too high, negative feedback pulls it back down. If it drops too low, negative feedback pushes it back up. It's basically your body's primary tool for maintaining homeostasis.
Let's actually trace exactly how this happens, step by step. Step 1 is the stimulus, some sort of change, like stepping outside into the blazing sun. Step 2 is the receptor. The sensors in your skin are what actually detect that heat. Step 3 is the control center. Your brain, specifically a part called the hypothalamus, processes that incoming alert. Step 4 is the effector, where your brain shoots a signal down to your sweat glands and blood vessels. And finally, step 5 is the response. You start sweating, your vessels dilate, your temperature drops, and boom, balance is restored.
If that still feels a bit abstract, just think of a standard house thermostat. You set it to a comfortable temperature, right? If the afternoon sun heats up the room, there's your stimulus. The thermostat, acting as both the receptor and the control center, detects it. It kicks on the AC, which is our effector. The cold air brings the temp down, which is the response. But here's the most important part. Once the room hits that target temperature, the AC shuts off. It doesn't just keep freezing the room forever.
And that is exactly how a negative feedback loop operates in your body.
Section 4. The positive feedback loop.
So that brings us to a very special, kind of wild exception to the body's standard rule. You really need to see the stark contrast here. While negative feedback hits the brakes to reverse a change and keep you stable, positive feedback slams on the gas. Positive feedback amplifies or strengthens a change. It pushes a process forward, intensifying it more and more, and it does not try to stabilize. It just drives something straight to completion.
Now, why on earth would your body want to intentionally amplify a change? Well, there are a few very specific scenarios. Take childbirth, for example. When a baby is ready to be born, pressure on the cervix triggers the release of the hormone oxytocin. Oxytocin causes uterine contractions, but those contractions push the baby harder, which triggers the release of even more oxytocin, causing even stronger contractions. It's this massive amplifying loop. Another huge one is blood clotting. If you get a cut, platelets rush in. They release chemicals that call out to even more platelets, and they just keep piling up faster and faster to violently and quickly plug the wound.
But here's the absolute crucial takeaway for positive feedback. It is a temporary override. It's not supposed to go on forever. That crazy amplifying loop in childbirth, it stops the exact second the baby is born. That runaway platelet pileup, it stops the moment the wound is fully sealed. Once this specific task is completely finished, the positive feedback loop abruptly shuts off, and your body happily goes back to its normal negative feedback balancing act. And finally, Section 5, why maintaining balance matters. So tying this all together, why does this complex biological dance actually matter to you on a daily basis? Well, because if these systems fail, things go south really fast. Without homeostasis, if you simply couldn't sweat, extreme heat stress would cook your organs until they failed. If your excretory system took a day off, you'd have a lethal toxic buildup of waste in your blood. If your blood pressure plummeted and your heart didn't speed up to compensate, your cells would literally starve from a lack of oxygen. Broken homeostasis isn't just an inconvenience, it is a direct one-way street to severe illness, organ damage, and death. To wrap up everything we've covered, this quote really hits the nail on the head regarding the tireless, totally behind-the-scenes work your internal systems are doing. The body is always working to maintain a stable internal environment, even when conditions outside change. It is essential for the body to function. Your nervous, endocrine, and circulatory systems, they aren't flying solo. They operate as this beautifully coordinated team, constantly making microscopic tweaks to keep you alive.
So as we finish up this explainer, I want to leave you with one final thought to chew on. As you sit here right now watching this, maybe you're feeling totally relaxed, just chilling out. What invisible feedback loops are secretly working away inside you? Is your pancreas quietly managing the sugar from your last snack? Are the blood vessels in your skin slightly dilating to adjust to the temperature of the room? Your body is this miraculous self-balancing machine, literally fighting for your survival every single second of the day. Stay curious and keep learning.